So the system that you can see in front of you here is one of Robotas's Mascot machines. This particular machine is a conveyorized Mascot, so this would be for a flow line way of working. You'll see it's a SMEMA controlled conveyor that you can see in front of us here. This particular system also has our clinch technology. So underneath the board, there is an X, Y, Z mechanism moving around under the board. So as the operator is picking apart and placing a part into the PCB, the clinch mechanism will come along underneath the board and will capture the pin, capture the lead, the component lead, and will bend the lead of the component underneath the board. So then pre-solder, you can actually turn the board upside down and none of the components will fall out. And also, if there are some components that are placed which have a tendency to topple over or fall over, then obviously this will make sure that they're dead upright and fixed in a position, so fixed to the board. Effectively, this is a workstation that an operator would work at. And at every step, they'd step on a foot pedal and the correct component is delivered to them in one of our carousels, ESD motorized carousels. So the tray will turn around and deliver just the right part. Or it could be delivered to them or indicated to them on one of our DPL arrays. So that's the system you can see here. So this is a shelf array with Pictolite LED strips on the shelves, which are indicating exactly whereabouts, which bin on the DPL shelf they need to be. All of our Mascots also have a laser head. So this is our laser head. Inside there's a laser projector, and the laser is shining straight down onto the PCB, and it's showing the operator exactly whereabouts on the board that part needs to be placed, and if that part has got polarity. So on our inline system here, the board would come in from the previous process. So it could be a Mascot before, or it could be a link conveyor, or it could be a machine stack, a PCB stacker or whatever. So the board will come in. It's just standard SMEMA conveyorized system. What you'll see is that the flip stop will come down. So as the board's traveled along here, it's hit a sensor here, which has told this build area here that there's a PCB coming along. So the flip stop, the board stop that this is now butted up against, has come down. And then because this has clinch technology, the rear clamp then came in and clamped the board to the front rail. So that's really nice and tight now. Now this board is now in position to where the laser has been programmed to where that needs to be. So on this board has got a barcode on it, which is linked to this particular PCB. So if I scan the barcode, the software automatically will bring up the correct assembly for this particular PCB. So the PCB, the program's opened up. Because we have clinch on this system, the clinch pin underneath the board has got a camera, and it's just asking me to confirm that the position of the clinch is in exactly the right position. So now it's moved to 2 alignment points here. Okay, so now the operator is ready to go. This carousel here is telling me that the component I need to pick is in this bin here. So I can take the part that's just been shown to me. I can see it's a capacitor. I can see on the software here, the top image on the board here is basically a golden board image. So that's the perfect populated board that I'm looking for. And on the screen here, it's showing me that on the top right-hand corner, that's where the component needs to be. If you look on the video on the PCB, there's a laser that's scanning on that particular component part, and that is telling me exactly where that part needs to be placed, and that this part has also got polarity as well. And then the bottom image here is just a zoomed in image of this area on the top golden board here. So now as the operator, I can have a good look at that, and I can see that the part I've picked looks exactly like that. I can see which way round the polarity needs to be. So now I just need to put the part into the board. So I've put the part in there. Now, because this system has clinch, I need to keep my finger on the part, step on the foot pedal. The clinch pin underneath the board is going to come up and clinch this component leads. So I've stepped on the carousel, on the foot pedal, sorry, and we've moved on. That component is now clinched to the board. Now you can see this next part is held in one of our on one of our DPL arrays, and hopefully you can see that this light bar has lit up, but only underneath this bin. It's not telling me to pick from this top bin or anywhere else. It's just telling me to pick from this bin. I pick this part here. I can see it's an IC. I can see that where the laser's telling me to be, so it's sort of on the center to the left-hand side a bit. This part also has polarity, so I can use that as an indicator to make sure that the part's going to be placed correctly. The laser is doing a box scan around the component there. So now I just need to place that component into the board. Okay, so that IC is now placed. Now, this IC has been programmed to clinch all 4 component legs. And with the clinch, you can program whether you want the clinches to be bent, well, in 360 degrees. So in this instance, I think the clinch legs are told to be clinched and bent outwards. But depending on what's happening on the underside of the board, you might choose to have your clinch to be clinching in any direction. So again, I'll keep my finger on the board just to keep the component in place. I step on, and underneath the board, the clinch is doing an X, Y, Z clinch of those 4 leads. That component is now fixed. Now the next component is coming from my carousel, so I can take that part. I can see that this part is a capacitor. And again, I'm just following the laser. This part does not have polarity because the software is telling me that. And I can see also that the laser scan is telling me there's no polarity on this part. So I'm going to put that part into the board as well. Step on the foot pedal, underneath the board, the clinch pin is clinching that component. When the board is finished, the flip stop is moving up, and the board is just moving on out to the next position. That could be another Mascot again, or it might be going straight into a selective solder or something like that. So they're the 3 components that we've just placed. And those components there, I'll try and stand out of the way, but they are clinched into the board. Sorry, it's a bit difficult to show you, but yeah, you can see that those components are nicely fixed. They're not falling out at all because they've been clinched to the board there.